Welcome to qnawire.
Okay, so in this problem, we have to find the angular acceleration for three different scenarios where we're given the speed and the velocity. So let's look at our first scenario over here. So we know that the equation for angular velocity is equal to v squared over r. And if you don't remember where that comes from, I'm making a quick note down here. We know that by Newton's laws, F is always equal to mass times acceleration, and the centripetal force is equal to mv squared over r. So therefore, we can cancel out the m's, and then we know that our angular acceleration, because we're working with the centripetal force, is v squared over r. All right, so all that's left to do here is to plug in our numbers. So we know in this case that our speed is 12 meters per second. Plug that in and square it and divide by 0.5 meters. And when we plug that into our calculator, we're going to get that that's equal to 288 meters per second squared. And if you were skeptical about this answer, you can check that it's correct with the units. So our m squared on top and our m on the bottom cancel out, so we get just m and seconds squared under it. And meters per second squared is, in fact, the correct units for angular acceleration. So let's move on to our second example. So here we have an infinite radius. So we're going to get 35 meters per second squared over infinity. And that is actually going to be equal to an angular acceleration of 0. And so that's because when you divide by a larger and larger number, your answer is going to get smaller and smaller and smaller. So when you divide by an infinitely large quantity, your answer is just going to be 0. So in this case, we have no angular acceleration at all. All right, so now our third example. Same formula, same process, we're just going to plug in. We know that our v is 2.3 meters per second squared, and we're dividing that by 1.8 meters. All we're going to do is plug that into our calculator. We're going to get that that's equal to 2.932 meters per second squared, which we're just going to round to 2.9 meters per second squared.